Hello, Assalamu alaikum everyone. My name is Aisha Khalid and welcome to my channel Math Madness by Aisha Khalid. So in today's class, we are going to start with S2 and the first topic that I'm going to discuss is continuous random variable. This is a very easy topic and I'll quickly go over the concepts that are there in this topic and then move on to the past paper questions. Alright, so the different probability functions can be represented through different graphs. For example, you can have a linear probability function, you can have a quadratic probability function, you can have an exponential probability function, any sort of a function. Now, how do we write that? So the function is equals to whatever it is, and the limits of the function are a to b, 0 otherwise. This is also called piecewise function. When you do more math, then you understand that. Now a to b is called my full limit. Why is it called the full limit? Because when you integrate the function with full limit, the entire probability is equal to 1. Remember, area under the graph. This is something that you know from S1. Area under the graph gives you probability. And complete area is equal to 1 because the total probability is always equal to 1. So the first concept is when you integrate the function with its full limit, the answer is equals to 1. So I'm going to make a box out of it. Now, the next thing is when you want to find out the mean or the expectation. How do we find it out? To find out mean and expectation, we multiply function by x or by the variable, you can say. We integrate it with full limit. Meaning x f of x integrated with full limit. We get the expectation. So second concept of the chapter. Third concept. How do we find out the variance? For variance, number one step is multiply f of x by x square, or you can say any variable that you have. Integrate it with full limit. Subtract square of the expectation. That means if you have to find out the variance, you have to find out the expectation. You don't have a choice. So you multiply the function with x square, then you integrate with full limit minus expectation whole square. Again, a very simple formula. Now, the fourth thing. How do we find out the median? So you know median divides the data into two equal halves. So if this is my graph and this is my median, this is my starting limit and this is my ending limit. So you know median divides the data into two equal halves, meaning the probability before the median is 0.5, the probability after the median is also 0.5. Therefore, what we can, to find out the median, we take median as my upper limit, a as my smaller limit because a is my initial limit, and when we integrate the function, we get the area is equals to 0.5. Now, let's talk about lower quartile. Lower quartile is the first 25% of the data and the rest 0.75% of the data. So if this is the lower quartile and this is my initial limit A and this is my final limit B. So how do we find this out? If lower quartile is my upper limit, A is my initial limit, when you integrate the function, the probability is 0.25. Or when you keep B as my final limit and lower quartile as my initial limit, the area for that is going to be 0.75 in a lower quartile. So we use this, but sometimes if the question might require you to use the second one as well. So you should have this concept. Now upper quartile. So this is my graph, this is my upper quartile. Upper quartile is 0.75% of the data. And the rest of it is going to be the 25%. Now, integrate f of x with upper quartile as my upper limit, a as my initial limit. The entire area is going to be 0.75. First concept. Or, if you use the upper limit with the upper quartile as my lower limit, the area is going to be 0.25. Alright, so let's start with the past paper question. The first question is, the average speed of a bus on a certain journey is a continuous random variable with probability density function given by this. Show that the value of k is equals to 70. So in the first concept that I told you is that when you integrate the function with full limit, the answer is equals to 1. So let's integrate the k upon x square with the limit 28 and 20. Now, let's take the x in the numerator plus 1 to the power divided by new power. Put the limits. Minus k upon x. Minus k upon 28 minus k upon 20 is equals to 1. Now, minus 1 upon 28 plus 1 upon 20 gives you 1 upon 70. So the value of k becomes 70, that's shown. Now, let's move on to the second part. The second part says that we have to find out the expectation. Remember, for the expectations, I told you, you have to multiply the function by x and then integrate it with full limit. So let's multiply x by k upon x square and then integrate it with the limit 28 and 20. This cancels out, so we are left with k upon x. I'm not substituting the value of k right now. I'll input it at the end. Now k 1 upon x. This 1 upon x will integrate to become k ln x. Because you know, if there's a differential in the numerator, function in the denominator, when you integrate it, it becomes ln f of x. So, k outside, ln 28 minus ln 20. Take the ln common out, 28 upon 20, and the value of k is 70. So, 70 ln 7 upon 5. That's going to be my expectation. Now, let's move on to the third part, which says find the probability that x is less than the expectation. So it means expectation is my upper limit and my lower limit is 20, and I have to find out its probability. So how do we find out the probability? Kx minus 2 plus 1 to the power divided by new power. What is 70 ln 7 upon 5, and this is 20. So it becomes minus, the value of k is also 70. I'm now going to input the value. See, so I input this in the value of k as 70 and the value of x as 70 ln 5. And then next time I input the value of k as 70 and the value of x as 20. So let's take I can also take the 70 common out. Not necessary. So this cancels out. Minus minus is a plus. 0, 0 cancels out. It's a 7 upon 2. Let's evaluate it. Minus 1 divided by ln 7 upon 5 plus 7 upon 2. So this gives me 0.527 as my answer. Now, let's look at the fourth part. Hence, determine whether the mean is greater or lesser than the median. Hence means use the answer above. We have to determine the mean is greater or less than the median. Okay, let's make a rough graph. This is the graph. Median means that the probability is 0.5 to the left and 0.5 to the right. When you talk about the expectation probability is 0.527, which is more than 0.5. It means the mean is going to be somewhere here, so that the entire this probability can be 5.527. So it clearly means that the mean is greater than the median, because the probability is more than 0.5. A random variable x is probability density function given by this. Find the probability that x is greater than pi by 6. So you know, I just need to find the probability that it's greater than pi by 6. So pi by 6 can be somewhere here. And this is the area that we need to find out. The upper limit is pi by 4, lower limit is pi by 6, and the function is root 2 cos x dot dx. Whenever you have to integrate, dot dx is important. Alright, now, what is the what is the integral of cos x? The integral of cos x is sin x. Put the limits, pi by 4 and pi by 6. Alright, so let's input the limits. Let's input pi by 4 first. So I get root 2 upon 2. Then input pi by 6, I get a 1 upon 2. Upper limit minus lower limit. So a root 2 minus 1 upon 2. There's a root 2 outside. So when we multiply, it becomes 2 minus root 2. Individually divide. This is what it becomes, which is 1 minus root 2 upon 2. Gives you 0.292. Now, let's move on to the second part. The second part says find the median of x. So you know, for the median initial limit, when you integrate the function, the area is equals to 0.5. So what is the integral of this function? It's root 2 sin x. Limits are median and 0. This is equal to 0.5. Root 2 sine m minus root 2 sine 0 is equals to 0.5. Sine 0 is a 0. So this finishes off. Root 2 sine m is equals to 0.5. 0.5 divided by root 2, we get a 0.353. Sine inverse gives you m. So my answer is a 0.361. This is my median value. Now the third part. The third part says we have to find out the expectation. Remember, for the expectation, we need to multiply the function with x and then integrate it with the full limit. Now the problem here is I can't integrate x by cos x directly. I have to use integration by parts. And the rule is LIATE or I late. Same thing, no issues. Algebra and trig. When algebra comes first, you take this as u and the other part is taken as cos x. I'm going to take a root 2 outside. So integral of cos x is sin x, and differential of u is, we have to complete this set to be able to apply by parts. What is the formula? uv minus u bar v. uv minus u bar v. What is the integral of sin x? The integral of sin x is minus cos x. X sin x plus cos x. The limits are pi by 4 and 0. So let's input those. 1.262 when you input the upper limit, minus when you input the lower limit. Cos 0 is 1. I'm not showing the working of putting the limits. Let's do that. Pi by 4 sine pi by 4 plus cos pi by 4 minus 0 sine 0 plus cos 0. So we get 0.262. That's going to be my answer for the expectation. Let's move on and discuss one more question. All right, show that k is equals to a plus 1 upon a. So I just randomly take out past paper questions. Sometimes the years are not visible, but that's fine. Understanding the concepts is more important. The time x hours taken by a large number of runners to complete a race is modeled by probability density function. Show that k is equals to this. Okay. So we integrate the function with full limit And we know that the probability is equals to 1. K upon x plus 1 the whole square, a0 equals to 1 dot dx. K x plus 1 to the power minus 2, add 1 to the power divided by new power into the differential of the inside expression. Minus k upon x plus 1 a0. Minus k upon 0 plus 1 equals to 1. Minus k upon a plus 1 plus k upon 1 equals to 1. Let's take a common out. Let's take k common out. And let's take LCM inside. This cancels out. K is equals to cross multiply. And this is exactly what they want us to show. So lots of mathematical calculations, okay? Second part, state what the constant A represents in this model. The largest amount of time or the longest amount of time taken by the last runner to complete the race. Because this function represents the time taken by the runner. So this means this is the final time. No one has taken more than a minutes. Okay, a hours. 3/4 of the runners take half an hour or less to complete the race. Okay. So f of x, since they're taking as hours, so I'll take half an hour as 0.5. 0.5 till 0. This is equal to 3/4. Okay, so let's integrate the function. Integrating the function means k x plus 1 power minus 2 plus 1 divided by new power into the differential of the inside expression. So this is what it becomes. Let's put the limits. I'm keeping the k outside now. Just the k, not the negative sign. So this becomes minus 1 upon 0.5 plus 1 minus 1 upon 0 plus 1. So 0.5 plus 1 is a 1.5 minus 1 upon 1.5 plus 1 upon 1. This gives you 1 upon 3. K is equals to 9 upon 4. Now what is K? K is A plus 1 upon A equals to 9 upon 4. That's my answer. Now, that's about it. Now stay tuned to my channel because I'll be discussing more questions in my next video. Take care. Allah Hafiz.